Hello, and welcome back to Velodyne Lidar Live. I'm Jane Maynard, Senior Manager of Communications at Velodyne, and I will be joined today by Asad Lesani, CEO and co-founder of Bluecity. Today's Tech Talk is part 2 of a series looking at the questions, why intelligent infrastructure and why now? Today, our focus will be data-driven infrastructure in urban planning. Before we begin, a few quick notes. At the end of Asad's presentation, we will have an open Q&A. You could submit questions anytime during the webinar using the Q&A button at the bottom of your screen. We will address as many as we can at the end of the episode. In addition, we will be emailing the recording of today's webinar along with the recording of part 1 of this intelligent infrastructure series. So keep an eye on your email for those recordings. Before we get to Asad's presentation on urban planning and intelligent infrastructure, we wanted to provide a quick background on Velodyne Lidar. Velodyne provides LiDAR-based vision solutions for over 450 customers worldwide. LiDAR is the technology that allows computers and machines to see the world in 3D. Our broad portfolio of surround and solid-state LiDAR sensors, of which you can see a sampling here, provide the quality, flexibility, and performance our customers need in over 25 industries. Some of these industries include industrial and robotics, intelligent infrastructure, and automotive, which encompasses both autonomous vehicles and advanced driver assistance systems, or ADAS. In addition to our LiDAR sensors, Velodyne Lidar also provides software solutions, including our LiDAR perception software, Vela, as well as the topic of today's presentation, Intelligent Infrastructure Solution. Intelligent Infrastructure Solution, also known as IIS, combines Velodyne's LiDAR with Bluecity's AI. We were so happy to join forces with Bluecity for this full stack hardware plus software solution designed to help governments solve some of their most challenging and pervasive infrastructure problems. IIS has already won multiple Smart City and Tech Awards, including the South by Southwest 2022 Innovation Award and the Smart 50 Awards. So what does IIS do? IIS generates real-time data analytics and predictions to improve traffic and crowd flow efficiency, protect vulnerable road users, and more, all while running 24/7, 365 days a year. The magic of IIS is that it enables civic and transit leaders to take a proactive approach to keeping their communities safe. With real-time data, cities can identify problems and then employ data-based planning. For example, with IIS, cities and DOTs can quantify near-miss data in real time to proactively improve roads and intersections before accidents and injuries and deaths occur. This will ultimately save lives. Okay, so now it's time to turn the time over to Asad. Asad will provide a quick overview of the technology behind IIS and then dive deeper into how the safety analytics generated by IIS can address multiple issues and provide insight into advanced urban planning. Thank you, Asad.
Great, thanks Jane for the introduction. And again, I'm happy to be here to talk about the IIS and the work that we're doing at Bluecity with in partnership with Velodyne. So I'd like to start giving a little bit of background about traffic management in general. So when we're looking at traffic management, we are basically looking at 4 different categories of activities. So starting with traffic operation, which means that how we can move vehicles faster, better in our road network, reduce congestion, which is basically doing traffic light optimization for a better and more efficient traffic management. And then we also have a traffic planning team that they are more focused on long-term planning and simulation of traffic in general to better understand traffic pattern and when it comes to the new infrastructure planning. So those are activities around traffic management with a focus on planning. And then we also have Vision Zero activities or in general activities around improving safety of road users, vulnerable road users specifically. And also the fourth category, which is on the future of mobility, we heard about a lot about connected vehicles, autonomous vehicles. The way that we should manage traffic management down the road, it's going to be a collaborative environment between infrastructure and also road users. And that's the part that future mobility team, they are more focused on those activities. But something that is important is the backbone of all these activities. So we have traffic data and insights that we can generate to feed this information to the traffic management, traffic operation planning, etc. So, when it comes to the collecting data, so we're basically looking at different type of technologies that each targeting a specific use case. For example, we use radar and inductive loops for traffic operation because they provide reliable data. And on the other side, we have cameras more focused on urban planning and safety applications because camera can provide multimodal traffic data, but it has its own issue with reliability and privacy issues. And then when it comes to the Vision Zero, now the question is that when we are collecting data, how we can convert this data into analytics and insights that we can use it to improve safety of road users, which means that potentially hiring third parties to run analytics and convert this information to traffic insights. And then on the fourth part, it's going to be application related to V2X or vehicle to infrastructure communication, which is more on real-time applications around safety improvement, which again, for those use cases, we need to also have a technology that can provide reliable and multimodal traffic data. So considering all these factors, so the current technologies to address the needs of data, reliable data in a multimodal traffic network, at the same time converting that data to analytics is really essential and key. And that's the missing part with existing technology. And that's where Bluecity comes in partnership with Velodyne to build a traffic monitoring system that works reliably in different weather and lighting conditions, which means that we can use it for traffic operation as replacement of radar or inductive loops. It's a multimodal system, which means that we can detect different type of road users and classify them as pedestrian, cyclist, vehicle, etc. It's a cost-effective technology when you compare it with existing technologies. Typically, we use a single sensor at the corner of intersections instead of having one sensor for each approach. And one of the interesting aspects about LiDAR is privacy protection. There's no way that we can collect any biometric data when we are collecting multimodal traffic data. And it's powered with our advanced analytics platform, which brings this solution as a turnkey technology for cities. So not only they can collect data, but also they can leverage our analytics platform to convert this data into insights that they can use it in their daily activities. That being said, our solution right now is being used in 4 different categories of applications. As you see here, it's on traffic actuation, traffic planning, which we covered in our last webinar. And this webinar, we are going to mainly focus on use of our technology for Vision Zero activities and future mobility. Which I'm going to talk about those use cases and applications. But before starting talking about the use cases, the way that LiDAR works for our application, when we install LiDAR at the corner of intersection, it generates a real-time 3D representation of whatever is in front of the sensor. And then in this case, it's an intersection in Irvine, California. And then we are connecting our sensor to traffic controllers. So that's why you see those virtual loops with different colors, because every 100 milliseconds we read signal timing plan. So we know which phase is green, which one is red, which again, as I mentioned, we use this virtual loops for traffic actuation. And then we have different type of APIs that we broadcast information we collect with respect to the location of the object, class of the object, speed, direction, and the bounding boxes around the object, which basically shows lengths and widths of object into different layers of application. So in our last webinar, we talked about using data for count, for counting, for speed measurement, for traffic actuation, and connection to the controller. But right now in this webinar, we want to mainly focus on passing this information into our segregate safety analysis and use of this technology for V2X applications. So that being said, the focus right now is road safety improvement. So road safety is getting a really like a challenging these days, especially when we have more people walking, biking. So just in US, last year we had, in 2020, we had more than 38,000 people died in road accidents, which even though during COVID we had less cars traveling on our roads, but we had 12% increase in the number of road fatality in 2021 in comparison with 2020. And also the average cost of road fatality per year in the US is more than $200 billion every single year, which about 50% of those are going is attributed to intersection road accidents and fatalities. So that's a big problem, that it has a social and economic impacts on our society. That's why cities and governments are spending a lot of money and efforts on finding ways that we can improve road safety in our road network. So they start with planning for improving road safety, but again, as a core, we need to have access to right data for that. So that's why we typically, in a reactive approach, that's the traditional way that cities are improving road safety. We basically look at crash data, so what police typically reports as accident in our road network. So then we can build a network of accident, let's say high injury network of in our cities. So then based on that information, we try to identify cause of accidents and issues related to accidents and road safety. So then we want to solve this issue. The main challenge with this reactive approach is that so we're not getting a lot of data. So even if you have an accident happening at the intersection, so you want to find the root cause, and then even if you you get the root cause of that accident, so then you have to implement a policy to improve that, and then you have to wait another couple of years to see the effect of that policy or modification that you might have in your road network. So this is not really efficient, and this is not a process that you can easily expand to other intersections. So again, you have to wait for a crash to happen to identify any safety issue. On the other side, we have a proactive approach on improving road safety, which is basically understanding the contributing factor in collisions and road accidents based on some measures and parameters, just as an example, how many near misses we have, how many red light runners we have at the intersections. With this proactive approach, you don't need to wait for an accident to happen to identify issues. And then it's going to be way cheaper for cities to identify root cause of root cause of safety issues at the intersection, with getting access to this information in a proactive approach. And the third part of this plan is more focused on how we can use real-time data that we're generating using existing infrastructure and sharing this data with, let's say, connected vehicles and autonomous vehicles to improve safety in more like active way instead of just analyzing and identifying issues. Just as an example, so sharing data with connected vehicles, it comes to, let's say, if you have a system that can detect pedestrian on crosswalk and broadcast this information in real time to connected vehicles. So that connected vehicle, when approaching the intersection, can get a little bit more information about what's going on at the intersection, especially during low lighting condition. So this is another approach that a lot of cities and government organizations are spending a lot of money on those use cases, which I think it's going to make our infrastructure ready for future when it comes to the stage that we have autonomous vehicle and connected vehicles. So I'd like to start with the first part of our analytics, which is conflict analysis. So in our conflict analysis, we're measuring a factor called post-encroachment time, which is basically PE, or post-encroachment time, or PET, is representing the time difference between a vehicle leaving the area of encroachment and conflicting vehicle entering the same area. So as you can see here, the shorter this time, the higher risk of accident will be at the intersection. So the whole idea again is to measure PET 24/7 for different type of road users, for different type of turning movement at different time of day. So then we can bring this information into heat maps at the intersection. So basically, these heat maps are showing location of the conflicts that we identify at the intersection. So as a user or as a city planner, you can get access to this information 24/7 when you have a sensor up and running. So the first part is going to be access to historical data, so you can play with the time range that you're selecting. So you can identify number of near misses or conflict based on type of road users involved. So let's say if you want to just target conflict between pedestrian and cars, you can filter out rest of road users involved in those conflicts, and then heat map will be updated dynamically. And then the other portion of the dashboard is basically gives you access to control overturning movement involving road users. Just as an example, if you want to just monitor conflict between cars going from north to south and south to east, south to west, so you can easily play with those arrow keys, so then you can update heat map dynamically. So definitely you want to identify conflict with between cars or pedestrians with cars that they have like a speed higher than a specific threshold, so then you can play with that slider. Or if you want to just target conflict with PETs less than a threshold value, typically PETs less than 2 seconds are considered as critical conflict at the intersection. So this part of dashboard basically gives you different options on generating conflict map based on the criteria that you want to have as a part of your data collection. And now that you have this heat map generated based on your criteria, so then you can click on those heat maps. So you can select those conflicts on a map, and then basically we show you a list of all these conflicts that you have on a map. Which basically starts with the location of the conflict, their timestamp, type of turning movement involved. For example, SN shows conflict between a car going from south to north, and then type of road users involved, their PET value, their speed, and also we give you access to a 10-second video clip, which basically you can go back over time and see what was exactly going on in that moment that we identify conflict. So not only you can visualize this information, but you can also manually validate what was going on in that moment. And then if, let's say, you want to put in a report, so you can simply click on this link, so then you can download this video clip, so then you can generate some reports. So this is an example of one of our projects in San Jose, California, which is basically shows you using our system, you're not just limited to a specific part of intersection. As you see, there's a pedestrian, or I would say jaywalker, on top side of this video, which is crossing the intersection, or there was a close call between that pedestrian and this car that is approaching the intersection. So again, with this approach, you can literally identify any close call or conflict between different type of road users within the frame of LiDAR data. So you're not just restricted to a specific part of a street. This is another sample between with a close call between a car going from west to east and a car going from north to south, which happened at 10 p.m. And getting access to this information, like disaggregated information, helps to understand when most of those close calls are happening, which type of road users are more involved in these conflicts, and also at what speed. So again, like you're getting a lot of useful insights about the root cause of those safety issues. For example, if you see a lot of close calls between a right turn movement and pedestrian crossing on crosswalk, so then probably you can extend the sidewalk, or probably you can just modify the curb at the intersection, so then you can get give a better visibility to turning movement vehicles. So again, like now that you have this information, you can identify a root cause, and then after changing or modifying intersection or playing with the signal timing plans, so then you can go back or go back again to the dashboard and see the effect of new policy or modification. So it's giving you a tool that you can easily use it for as a before and after study as well. So this conflict analysis mainly focused on one intersection, but using our PET rate, basically you can compare multiple intersections. So let's say if you have our technology implemented in multiple intersections, you can use PET rate to compare which one you want to prioritize if you want to improve the road safety. So PET rate is basically, it's the number of conflict per 10,000 vehicles. So it's not biased to the number of vehicle or traffic volume. So it's a normalized way of comparing number of conflict at the intersection. When you want to have multiple intersection, you want to compare these to let's say multiple intersection to prioritize improvement or new policies. So besides traffic conflict, the other parameter that we measure is red light violations. Basically, the way that the system works is, since we have access to signal timing plan in real time, we are overlaying signal timing plan with the location of the objects to identify if the car, if any car is entering the section during yellow or red. And basically that's what you see on the left side, which is a scatter plot of all those violations, which is basically, each single point is showing a vehicle entering intersection during red or yellow. And this scatter plot also helps to understand when most of those red light violations are happening, what type of turning movement, at which phase those red light runners are happening. And on the right side, you have also a list of those red light violation, which basically summarizes their timestamp, shows the phase that this car entered to the intersection. We're going to add speed of vehicle as well, so it's a reserved column for that. Class of vehicle, turning movement, and then there are two parameters here that it's enter at and leave at, which basically shows how many seconds after red light this car entered to the intersection. Just as an example, this was a red light violation detected in one of our projects in Austin, Texas. Which shows that there was a car going from north to south, and this car was at phase 4, and it happened at 5:30 p.m. local time. This car entered intersection 2.4 seconds after red light, and then left intersection 4.1 seconds after red light. So, and then exactly the same way as PET conflict analysis, you have access to a 10-second video clip, so then you can go back over time and see what was exactly going on in that moment. So again, like, this is another tool of monitoring red light violation and also looking at when most of those red light violations are happening in your network. And then, for example, if you want to send the police on site, so you can proactively know when most of those red light violations are happening, so you don't need to randomly send a police car to the intersection. So you can use this information to have a optimal solution for that. So right now, beside on the surrogate safety analysis, which is proactive approach, we also use our technology as a way to communicate with connected vehicles. And basically, the way that our system, this is one of our POCs that we are doing, we're doing in Europe. It's a sensor that installed at the corner of intersection. You see the LiDAR, and it's connected to our edge computer, and an edge computer is also connected to an RSU roadside unit, which broadcasts safety messages to connected vehicles. In this case, we have on right video, you see that there's a red vehicle, which is our pilot car. This car has an OBU with its display, which basically shows received information from roadside unit. If you play more, you see that there's a warning that there's a cyclist approaching intersection, and you see that cyclist. On the left side, you see another case that this car is approaching intersection and it's getting a warning from our system that there's a cyclist approaching intersection. And then if you play this video, you see that cyclist. That as a driver, you won't even see that before, like when you're receiving that warning message. So this type of application, it's more for future of mobility. It's but you know that most of new cars will have probably 5G or connected with infrastructure using OBUs or standard communication like CB2X or DSRC. So then making sure that your technology is ready for those applications is really important. So then you can minimize the extra cost that you might have in the future. So this is another use case that we are using our technology for safety improvement application. And this is really important for some, like even current application, for example, sharing this information with buses. So this is an expansion of this project. It's basically when they are doing right turn movement, so they can get this information in advance. So then we can improve safety of road users. So the other application which relates to safety is wrong way detection. This is an application that we're working on it. So it's our system monitoring two ramps, and this is one of the POCs. And basically what we are doing here is monitoring trajectory data of vehicles to identify wrong way drivers. So again, like this is another active way of improving road safety, and eventually the goal will be broadcasting this information to connected vehicles and displaying and showing messages on displays that which are advanced and like let's say closer to the entrance of these ramps to improve safety with giving more information about what's going on this ramp to the approaching vehicles. Just as a summary, so we talked about 3 different approaches on improving road safety. So a reactive approach, which is basically based on police reported crash data. It's we have to wait for an accident to happen so then we can improve road safety. But on the other side, we have proactive approach and sorry, and real-time approaches. So there are benefits of using Lidar when you compare with camera. Sorry. When you compare Lidar with camera, so with capturing safety issues with camera, it's going to be difficult when it comes to different weather and lighting condition. But with Lidar, we're not biased to skin color. We can bring equity to our society. And also, we make sure that we are ready for future of mobility with sharing data with connected vehicles. So we're also working on new measures of safety like time to collision, jaywalking violation. And also we built our API in an open API architecture, which means that we can share our API and data that we're generating in real time with our partners so that they can easily build new applications on top of our solutions. That was all I wanted to discuss, so I would be happy to answer any questions.
All right, we have some great questions. I'm really excited. Thank you so much, Asad. I have to say, when I went to Austin with you to present IIS at South by Southwest, I went home and I was a big nerd with everyone I talked to. After that, I was all excited about your AI and our LiDAR and all the potential of what it can do for traffic. So anyway, and it was very mind-opening to really see how powerful capturing near misses is in terms of identifying dangers before they happen. And anyway, and also V2X is just very exciting. So thank you. I love all of this, and you turned me into a traffic nerd while I was in Austin. So that's a good thing, right?
Yeah, it was.
All right, so I'm going to just get into the questions. We have a lot of good ones. I'll just go right in order. LiDAR is one of the costliest sensors currently, so is the IIS solution cost effective?
Yeah, so it's cost effective from different perspectives, I would say. The first one is, so when it comes to the solution in general, like all the hardware components, software, etc., it's competitive with existing technologies. It's definitely cheaper than existing solutions when you compare it with radar or camera-based technologies. But it also saves a lot of money for municipalities with respect to the concept that this is a single sensor solution instead of having multiple sensors, which reduces the cost of installation and maintenance for municipalities. And the other factor that is we're giving access to all this analytics 24/7. So they don't need to hire a third party to run analytics for them or adding a new technology to send someone to collect some data. So again, everything is going to be available 24/7. And I think the most important factor is that this is a technology that different stakeholders can use this technology for traffic operation, planning, safety. It's not like you have to put radar or loop for traffic operation because they are reliable, and then putting camera for traffic actuation, which they provide multimodal data. So it's a turnkey solution which helps with the cost.
Okay, awesome. Apart from classifications of pedestrian, vehicle, bicycle, is there further classes, such as within pedestrian, adult, child, or within vehicles, emergency vehicles, trucks, buses, etc.?
Yes, for vehicles, we have passenger vehicle, truck, buses. So we have some subclasses, for example, articulated buses, tram, and regular buses. So we have transfer trucks, trailer. These are all classified under our vehicle classification. For vulnerable road users, right now we just have pedestrian and cyclists. We're working on getting scooters as a new mode of, let's say, vulnerable road users. Yeah, these are the main categories of classes that we have.
Is developing new classes just something, how do you decide to develop a new class? Is it based on kind of what you see happens within the systems and what's necessary? Or is it just, we want to classify everything and that's our goal?
Yeah, so it's based on customer needs. Just as an example, we didn't have tram in our databases to train our deep learning models, but we had a project in Finland, and then the second project, which is in Dubai, which they have tram. So they want to classify tram as a separate class. So in the way that it works is, generally speaking, is that we collect some data from those installation, we train our deep learning models to add this as a new class of objects. Some classes are easier. So like tram was easier to classify with a small amount of data, but some subclasses might be more challenging because it's going to be very similar to other type of road users. So which might need more data to train our models.
Okay, cool. Okay, next is a PET question. Does the PET capture real crashes before they actually happened?
No, PET, so no, PET is not a good factor for capturing actual incident. The other parameter that it's going to be it's going to be correlated to the chance of accident, and at the same time we can potentially use it. It's called time to collision. So that's why we're working on getting time to collision to our system. And the main reason is that PET is we have to wait for the first object living conflict zone till the second object arrive to that zone. So then we can measure PET. But in accident, no one is living the conflict zone. So that's the reason that we can't use PET for that. But there are a couple of other factors beside PET that we can potentially use it in our safety analytics. And it was surprising in our project in Austin. So we had 3 crashes happening in that intersection. And then we were looking at our signal performance measures. We saw a sudden changes in the average speed of vehicles at that intersection. And also in the occupancy of vehicles back of stop line. So all these traffic patterns has changed quickly when that accident happened. So these are parameters that we want to potentially use down the road to detect incidents in real time and send, let's say, messages to dispatching department to dispatch emergency vehicles.
Okay, so when you were showing one of the intersection samples, they asked what height the LiDAR sensor is mounted. And, normally it is difficult to cover the complete junction, including 4 lanes with one 360-degree LiDAR. That's what they're thinking. So is it difficult? Do you need more than one? What's the height? What's the coverage? All of that.
Yeah, so we typically install between 4 to 6 meters height, depending on size of intersection. I would say just roughly for intersection with, I would say 6 to 7 lane per each approach, we should be good with one LiDAR to cover the whole intersection. But for larger intersections, let's say for our project in San Jose, that I think we have 6, 7 lane per each direction. In total, 10 to 12 lane per each approach. We have 2 LiDARs, but 2 LiDAR is the maximum LiDAR. And the way that system works is we put 2 LiDARs in 2 different corners of intersection, and then we fuse data coming from both LiDARs on our edge box, so we can still get one object. So yeah.
Awesome. Are they installed kitty corner or side by side? What's the when you
No,
do
so one LiDAR in, let's say, northwest, the other one southeast. So yeah.
Okay, yeah. Okay, cool. Okay, do you consider vehicles traveling in the same lane, going the same direction as a conflict, or are those filtered out so only paths crossing at an angle are considered a conflict?
Yeah, so for PET, we are now excluding those patterns of, let's say, because it doesn't make sense. We're going to have conflict between every single car traveling in the same direction.
Right.
So yeah, so right now we're excluding those in our analysis. So it's based on road users with turning movement or true movement with pedestrians.
All right, great. Okay, what kind of edge computing device are you using to process the LiDAR?
So yeah, we're mainly using NVIDIA Xavier AGX in our system. So yeah.
All right. Which LiDAR is used in traffic analysis? And we already answered the height question, but which LiDAR are you using, or what LiDARs can you use?
Yeah, so the answer is the higher resolution, the better data, the longer range, the better coverage area. But we typically use I would say 90% of our project, we use VLP 32 channel LiDAR, which is
the Ultra Puck, right?
Yeah, it's Ultra Puck. It has 32 channel, 200 meters range. With that system, we are reliably detecting vehicles within about 70, 80 meters radius around LiDAR. For vehicle detection for pedestrians, it's something around 40, 50 meters. We do have projects, for example, with New Jersey DOT that we're using Alpha Prime, which is 128 pixel LiDAR. With that one, definitely we have higher resolution. So we are tracking vehicles something around 120 meters away from LiDAR. And for pedestrian detection and classification is something around 70, 80 meters with Alpha Prime.
Okay. A follow-up, somebody asked about the LiDAR specs, which you just went over. Can you detect children with 32-line LiDAR?
I would say it's going to be detected as a pedestrian. We're not like classifying them as
right.
Yeah.
Mm-hmm. Yeah. So yes, it detects all pedestrians, right? Do you provide an end-to-end application including hardware and software? Yes, right. It's the full.
Yeah.
I mean, maybe just talk about. We haven't really talked specifically about what pieces are in the application, so or the solution. Maybe we can just go through that quickly.
Yeah, so there are 3 hardware components. One is the edge box. It's a ruggedized certified system that we have. We have a partner that they are manufacturing those edge computers. It's a ruggedized IP67. So the second piece is a PoE splitter, which brings power and data from edge box to PoE splitter, and then PoE splitter will be connected to LiDAR. So the full system includes power supply, edge, PoE splitter, LiDAR, cable, power supply. So, yeah.
Okay, great. When you mount the LiDAR at, say, 5 meters, is there a blind spot near the LiDAR up to a certain amount of meters, and how do you handle that?
Yeah, so typically there is a like blind spot about 2.5 meters or 3 meters, depending on the size of the height. Typically, we try to choose poles that they're a little bit away from edge of the intersection, so to minimize that issue. And the other thing is we're working with Velodyne to have new lidars specifically designed for like more like all below horizon laser channels. And also for short term, again, like we are thinking about adding solid state lidars from Velodyne to our system. So then, but typically we don't have a big issue because poles are still a little bit away from the edge of the intersection. So we should be good.
Okay. Somebody said perhaps they missed it, but they didn't. It's a great question. Can you discuss the hardware connection setup? Hardwired, fiber optic, Wi-Fi, direct to cloud. What's the connection?
Yeah, so if you use the system for traffic operation, so you can connect it to the controller over NTCP. So you just have typically in this traffic cabinet, we have a traffic switch, which is connected to the controller. So we connect to the same switch. If the city has its own network, like fiber network, so we can use that one to transfer data. With respect to the security, we're not asking to open any inbound port in city firewall, so which is good point. So then we can improve safety, security of system. So all the connections are outbound connection from our edge box to our services. So for traffic operation use cases, which means that feeding data to the controller, we don't need to have any connection at all. But if we want to get access to the safety analytics and all the measures, so we use internet to transfer this data to our cloud platform, which is basically it's a metadata, not raw LiDAR data. In that case, we have a different option. We can use city fiber network. We have built-in LTE modem in our system as well, so they can put a SIM card and then they can get data.
Okay, cool. Following up on the pedestrian question, what is the detection accuracy for pedestrians with a 32-line LiDAR?
Yeah, that about 40 meters range that I mentioned, we are reliably detecting pedestrian. Detection is different than counting. I'm going to explain that. So with respect to the detection, it's more than 98, 99% accuracy on pedestrian detection. Definitely it's different than counting, because if we have like two pedestrians at 40 meters just walking side by side, at some point we might miss one of those, and or maybe we detect both as one object. So that's why like detection accuracy is really high. It's again like 98, 99%. But for counting accuracy, it's something probably it could be something between 80 to 85%, up to 95% accuracy for pedestrian counting.
Okay, cool. Is IIS solutions deployed anywhere that is not an intersection?
Yes, we
mostly
do have
at intersections. Yeah.
No, we do. We have a project with New Jersey, which is it's 16 location. One of the locations is it's a highway application. In Dallas, we are implementing in 4 locations, which they are highway. What else do we have on? Yeah, and then yeah, these are the highway application other than intersection. So yeah.
Okay, cool. How hard or difficult is it for an urban planner or a city worker, traffic management worker to use IIS, and what's the interface like for them?
Yeah, so with respect to the installation, if there is no need to connect to the city network, it's going to be super simple. So all we need is an AC power in a pole, and then installation typically takes less than 2 hours for cities.
Cool.
So if you want to connect to the city network, so in that case, we can place EdgeBox inside the cabinet, or we can place EdgeBox on the same pole that we have LiDAR. Still, it's going to be easy, but there should be some wiring from EdgeBox to the traffic switch, which again, like it shouldn't be difficult. We typically use the same pole that is just beside traffic cabinet. So after setting up the sensor, we're going to always have remote access to the system, so we can upgrade software or add any additional feature to this. And the user and the urban planners, they will get access to this data using our dashboard. We're going to create user accounts for users, so then they can get access to this information, historical data, they can visualize, they can download, or if they want to use our API to automatically retrieve this information, they have this option as well.
Awesome. We already talked about cost, that came up. Let's see. What are the benefits of the fact that the system is used 24/7 over long periods of time?
Yeah, this is a really good question. So first of all, there are studies showing that more than 70% of road accidents are happening during low lighting conditions. So that is really important to have a system that can capture this information about safety issues during low lighting conditions. So that's one reason. And the other reason, the other factor is that traffic safety issues might be different at different time of day, different time of year, different weather condition. So if you really want to find the root cause you need to get access to this information for a long year period. So for example, one of our customers, they have a Vision Zero plan, and they are using our solution for 1 year as a before study in different locations to collect this information to have a conclusive let's say, finding about the root cause of safety issues. So then they can adjust or modify infrastructure to solve it, and then use the system to see if that new policy or modification is effective or not. So, so this is not something that you can probably just capture with a couple of hours of video recording. So you really have to have a longer period covered to get more comprehensive information.
Cool. All right, well, we are right at time, and that's all the questions. Perfect. It's like the question gods are shining down on us right now. So, all right. So no, we did answer all the questions, but if you have further questions that we didn't address, our contact information is right there. You can feel free to reach out to Asad or reach out to Velodyne, and we can get you in touch with the right people. In addition, if you go to velodynelidar.com and click on products, you'll find infrastructure. And you can also just go to vldr.events/IIS, make sure it's all lowercase, and that will take you directly to the product page for IIS. You'll find lots of great information, and you can also schedule a meeting with an expert. So you can get one-on-one time to ask and answer further questions. Okay, thank you, Asad. This is amazing. As always, it's such a powerful solution. So we're really excited to be working with you on this and getting this deployed everywhere. Stay tuned for our next episode of Velodyne Lidar Live. It's coming up. We will be sending out an email and posting on social media with all of the details, including time, date, who will be involved, all of that, and registration information. As always, if you register, you can access live and then also get a recording afterward. The next episode is going to include a roundtable with several of our customers, including Renewbot. So, Renew Robotics. Renewbot is their product. Tim Mattis, the CEO and founder of Renew Robotics, will be there to discuss their solution, which is Renewbot, which is a management system for mowing grass, taking care of the grounds at energy and solar facilities. So it's a really neat application. It's tuned into sustainability and uses LiDAR for autonomous work on their mowers. So if you're interested in that and want to join us, like I said, stay tuned. We will email you. We will post everywhere and let you know when that is. Thank you so much for joining us today. Keep an eye on your inbox because we will be sending you the recordings for today's webinar, which was part 2 of this series, as well as part 1 with Asad that we already had. So you can get all the information, watch it again, take more notes, and as always, feel free to reach out to us. Thank you so much and have a great weekend.